a graph of trigonometric function part 3, and we're still in these 3 videos working with the same number. I'm trying to do things in details and slowly in order to understand every single detail we should do in every single exercise. We're almost done. We are in table of variations, and after that we draw, right? So x goes from 0 to 2 pi, passing through the following points we talked about, right? 0.615, it's less than, this is not 2 pi by the way. This is for sure not 2 pi, it's pi over 2. Okay, it's pi over 2. Then we have a point 2.526 will be more than pi over 2. Then we go to 3.5757. Then we go to 3 pi over 2. 3 times 3.14 divided by 2 will be more than 3.757. And then we'll go to 5.668, which is before 2 pi, which is 6.28 approximation. We are talking about approximations here. Where do I got these points? I found them, right? I found all the different values of x, their corresponding values of y's here and at the beginning, if you remember, right? 0, 0 to pi 0. We find x equal pi over 2 here. Also, it passes through 0, 0, right? What else? What? This is wrong here. This is wrong. It's not 0, 0, right? X, we found it as pi over 2. Okay, you see? When we finish and we are going to do the table of variation, we will notice all these points if some mistake happened, right? So probably you're saying that I did mistake. Okay, I did. We all do. But the most important point is to know how to correct our mistakes, right? Let's try to finish this. Okay, if x is 0, y is 0, we found this point 0, 0. If x is 0 point, x here, a derivative here is 0, right? And here is 0. We found all these values, 0, 0, 0, and 0, right? And if x is 0, y is 0. If x is 0.651, y we got it as 0.385. Okay, I will do them fast. Here we found y 0. Here we found y as 0.385. Here we found it as minus 0. You can go back to the previous video and you see how we found it. And by the help of your calculator, for sure you can find them really fast. 0.385. What else? Minus 0.385 and 2 pi. The f of x is 0. We substitute points between this to know the behavior of f prime. Here it will be positive. Between 0.615 and the pi will be negative. Between pi by 2 and 2.52, 2.56, I guess, 2.52, 526, right? Between pi by 2 and between 2.526 and 3.5757 will be negative, and between this and this will be positive, then it will be negative, then it will be positive. As we did it in class, right? We can find a point between these two, and we check by calculator. It gives me positive or negative. So the curve goes from 0 up to 0.385. It goes down to 0. This is correct. It goes up again to 0.385. It goes down to minus. It goes up to 0. It goes down to minus. It goes up to 0. We can know the signs of derivative from here, and sometimes not, but we can know it from here for sure. All right, now we're ready. We are very ready to draw. Well, I did already post the picture to save time. So now I will select this picture, right? I will copy it or cut it, whatever, and I will take it to a place which is near the table of variation. Let us guys discuss this picture as much as we can. We still have 5 minutes only. All right, if you can't see clearly, I just did these points again. This is pi over 2. This point here is pi over 2. Then it's pi, 3 pi over 2, right? 2 pi. What else? 5 pi over 2. Okay? We can notice that. I think so. We forgot the point on. We forgot to put the point pi also on. No problem. No, no, it's all right. Okay? We found it somewhere here. Pi 0, I guess. We found it to pi 0. And if x is pi, anyway, this is point of intersection between the curve and the x-axis, right? If x is pi, substituted in the original equation, sine pi will be 0. That's why sine x will be 0. That makes all the product 0. So we will have another point that cuts the x-axis, right? Which is pi 0. All right. These points here, small points here, unit on the y-axis is 0.1, 0.1, 0.2, 0.3, 0.4, and in the negative sense, negative 0.1. This is negative 0.1, negative 0.2, negative 0.3, and negative 0.4. All right. I'm just going to draw from 0 to 2 pi. And you know that the curve will repeat itself, right? It's very simple now. All right. We just put all these points on the curve. 0, 0. Okay. 0 abscissa, 0 ordinate. 0.615 abscissa. 0.385 ordinate, which is this point. Because pi over 2 is 3.14 divided by 2. This point is 3.14 divided by 2, which is approximately 1.57. 0.65, it's almost this point. Okay. 0.38, it's almost this point. So we put it on the curve. We put the point pi over 2, 0. We put the point, this point will be 2.526 and 0.385 again. This point will be pi 0. If x is pi, we just said, then y will be equal to 0. And then we put this point is very important because it makes all the points that makes the derivative 0 will be either local maximum or local minimum. And you already know that. This point is 3.575 and its ordinate is minus 0.385. This point has abscissa. This point for sure is 3 pi over 2. And this point is 2 pi. And this point is very important. It's 5.668 abscissa and ordinate minus 0.385. And that's it. We go look at the curve. Look at the behavior of f of x. It goes upwards from 0 to 0.385 ordinates, from 0 to 0.385 ordinate. It goes all the way. Let me redraw this function. It goes all the way from this point to this point. Here we have maximum point because it went back down again to 0 to this point. And then we have here local minimum. It goes up again to this point, and then it goes down, but we don't have local minimum. It cuts the x-axis. That's why I found the point pi, which makes the y equals 0. Now it goes to the down minimum point, local minimum, local maximum again to 3 pi by 2, and then to local minimum again, and then it goes up to local maximum again, right? When we finish, we can, if you want, right, draw a part as we started in this part over here, and then a part down, just to tell him that it's not only from 0 to 2 pi, but it continues. That's it. It's done. Take your time checking this problem, please.